So I've taken the first few steps in importing a video and recording some video motion data, and what I have here is a series of coffee filters being dropped, and I selected this coffee filter right here to record and collect the data for it. Here's the video for you. Alright, so as you can see, I've already gone through the process of collecting data. Well, let me show you a couple problems I ran across, and I'd also like to show you how to clean up your data table and perhaps add some columns that you might be missing. So what I've got here is my data, and one thing I want to point out, when I actually went to put in my XY axes, my coordinate axes, you will notice that if I were to leave them as a vertical axis as we put them in, I can't even get them to be vertical anymore. About right there. That's vertical right there. You'll notice that this red pole is either very crooked in our school, or more likely the camera was mounted a little bit crooked. And that's really not too hard of a problem to figure out. And so what I can actually do is you can actually grab this little dot on the lower right of the axis, and you can actually rotate your axis to actually line up. And I actually did this initially. I moved it. I set my axis right along the edge of the pole, and I actually lined it up along with the pole, and then I shifted my axis over to run through the middle of the starting point of the coffee filter. And then I just ran the video real quick to make sure that the coffee filter fell down this line, and sure enough it did. So that just shows us that our camera was off at an angle. In the foreground here, actually it's not the foreground, it's actually in the same plane as our coffee filters are dropping. We taped a meter stick to the pole, and the distance from the floor to the top of this pole where they're dropping from should be 5 meters. And this is something you want to check after the fact. In fact, you can look up top here, and this is showing your coordinates in space. And if I go down to my 0, 0, which is right here, you can see up top in my video screen I have 0, 0. And if I move this up, I should be up at 5 meters, and really I'm at 4.55 meters. So something's happening here. Even though I have a meter stick taped into the foreground, for some reason I'm only showing 4.55 meters of height being transited from top to bottom. And if you were to go out to the hallway and take a tape measure and measure that, you'd see that's at 5 meters. So my question to you is, what's wrong here? Is my meter stick wrong? Or is there a little bit of error on my meter stick? So this is not a small error. I'm at, up top here, I should be at 5 meters, but I'm at only 4.55, 4.6 meters. So that's a significant error in your data. And the question is, why is that happening, and can we correct it? But basically, this 1 meter distance that I chose right here, there's something wrong with it. So really, I think I'm going to readjust my ruler to be the height from the floor to where they're dropping. That's supposed to be a 5 meter distance, and I've measured that before, so I know that's true. So I'm going to use that as my 5 meter distance. So now you'll notice if I come up to the top of it, sure enough we're at 5 meters, and down here we're at 0. That's what should happen. So be careful. All right, so I already collected this data. I'll leave this data the same. I actually used my movie options. This movie was shot at regular frame rates. It ran for about 2 seconds, I'd say, so that would give me about 60 data points. I didn't need that many data points, so I actually advanced the movie every 3rd frame to collect my data. I'm starting my first point at time 0, and then I went through and added my VA points, and it popped this graph up for me. All right, that's pretty good. I've got a nice graph showing up here. Do I really care what's happening in the X direction? No. How do I get rid of that? That's really annoying. What I'm going to do is I'm going to right click on my graph, hit the graph options, and this allows me to select exactly what I'd like to plot on this graph. And I don't want the X plot on the graph. I could plot time on here, but that's sort of useless. You can try it out, see what happens. And if I had X and Y velocity data, I could put that on the same graph I want. Let me just show you what it looks like with the Y velocity on here. And so here it's plotting both my velocity and my position on the same graph. Interesting way to do things. It sort of constrains you in terms of your scales to X on the graph. You can't get the best looking scales. So I like to try to do one variable at a time per graph and just plot multiple graphs. So let me get that velocity back off of there. But you might in the future want to use that. But like I said, actually you can use a dual axis scale. Watch this. Here's a dual axis scale. So on my right axis, I can plot my velocity and watch what happens now. And it'll auto scale this graph for me. Then this is a nicer setup here. You'll notice I have a scale on the left here with the y values, and I have a scale over the right for my velocity and the y values. And that corrects that little problem I have with everything being squeezed a little bit too much. I really don't like the fact that this starts at -1 up here. I like the things that start at 0, so I think I can probably correct for that. Auto scale from 0. I'll make sure this is auto scaling from 0 as well. And you'll notice now I have, here's 0, and here's all my negative velocities. Here's 0, and here's up to 5 meters. So that's not a bad setup for a graph where I have two different scales and I can see a nice big graph for each. But once again, you know me with my position, velocity, and acceleration graphs. I like to have 3 graphs stacked one over the other. So that's what I'll do. And I'll show you how to do that. So let me go ahead and let me click off my right axis here. And we'll just go with a single graph for position versus time. Alright, so there's my position versus time graph. And then I was looking around and I said, oh, what are all these graphs underneath here? These graphs automatically showed up for me because I had a sonar sensor plugged in, and it automatically detects any sensors you have plugged in, and it automatically creates the graphs as if you're going to use those. Well, I didn't actually use those and collect data from those, so these data columns that you see over on the table on the left side here are empty because I never collected any sonar data. And so I have 3 empty graphs and an empty table here. Well, that's annoying. I don't really want to see any of that stuff. The graphs are pretty easy to take care of. I can just click on the graph and delete. So I'm clicking on the graph and deleting, and I can get rid of these graphs. But I still have all these tables here that I don't really want. And you can see over to the right here is the data I would like to use. So it'd be nice to get rid of these excess columns. And if you right-click on the table, go under Table Options, you can actually click on things that are displayed and remove those from being displayed. And now the only data being displayed is the data in my columns that I would like to see. And as I said before, I really don't care about the motion left and right of this object. We're studying the up and down motion of this falling coffee filter. So I'm going to take out the X data sets as well from here. And there's the data I'm really interested in. So it's nice to be able to have this data visible and relatively small off to the side. So now we can actually go ahead and come up with our graphs. So there's my velocity versus time graph. I'm going to add in another graph, insert graph, and look what it's pulling up. It's pulling up an acceleration graph from that data I never collected. But I can click on this graph, graph options. I right-clicked on the graph. And I don't want to plot acceleration from this set. I want to go down to the video analysis data, and I want to plot my velocity. I'm going to make sure I'm auto scaling from 0. I like to see the 0 in there. And there's my velocity versus time graph. And I'm going to squeeze this down. And here's my display with 2 graphs in it. And I can, change make the top one a little bit smaller and the bottom one bigger or whatever. But I like to see some nice stacked graphs. And I also like to see my scales, my time scales perfectly aligned here. And the reason it's offsetting a little bit because this is coming up with a decimal place here. Let me see if I can fix that here. I think if I were to pick a scale instead of 0 to -2.4, if I actually manual scale from 0 to maybe -3, it might use integers only for me. And there you go. So now these axes, I should be able to match these up. Another thing I don't like about these graphs, I don't like the size of these bullets is too big, and I hate these little blocks they used on here for units, and so I think I can change that as well. So for my options, if you go over to the options, you can see here are the different shapes you can choose. I don't mind the circle, the filled circle, but I just don't want like the size. So if I go with a small versus a large, that's a little bit better looking shape if you ask me. You can change the color if you don't like the color. In fact, I don't like this yellow either. I'm going to get rid of the yellow. Column options, video Y. Let's change the color. I like red. We'll go with red. Alright, done. I'll do the same thing with this one. I hate these little options here. We'll do, this is our y velocity we're changing. Let's use a different shape. How about if I use, well, we use a circle. I'll use a circle still. We have a separate graph for it. Color, I'll stick with red still. And I'm going to go with a small dot. I like that better. And you'll notice it changed the column color as well at the same time to match that. Now the other thing that I need to do, I would really like to plot the acceleration versus time for this set of data. Even though technically we don't collect acceleration directly, this program will actually calculate using calculus, or maybe do a simple calculation of delta V over delta T for each time interval and come up with these average over these small time intervals and plot those. I'm not sure the exact techniques they use, but you could probably do a few calculations yourself, try a few different methods and see which match. But let's see if we can add a brand new column of data here. So I'm going to put in a new calculated column. You could also put a blank column in and manually add the data points and do your calculations yourself. Let's try to have them calculate all the values for us, see what happens. So let's put a name. Let's call this y acceleration. And for short, we'll call it AY. Our units are going to be meters per second per second. I don't know how to do a square on this with a superscript, so we'll leave that as is. Oh, hold on. Yes, I do. Superscript 2. There we go. I will use the video analysis data set on this. The expression, what I would like to do, let's check out functions here. What I'd like to do is use a little bit of calculus. I'm going to take the second derivative of position with respect to time. Inside these parentheses, I will need to put in the variables I would like to take the derivative. I want to use the position, the y position, comma, and the other variable I'm going to put inside of as an argument to this function is time. So this tells me to take the second derivative of my position with respect to time, which, as you know, is the acceleration of the object. I hit done, and here's my new column of data. I'm going to go through and revise this a little bit. So my column data, I'm getting a double parentheses here, so I don't have to put in my own parentheses. It does that for me. I don't want purple. I'm using red on all these things, and I'm just going to go with circles on all these since I have my own graphs. I'm going to put a small red circle when I graph. Done. But now I have to create a graph. I'm going to insert graph acceleration. Yeah, but is this my acceleration they're talking about? There's no data here. It must not be. So I'm going to hit graph options, and under graph options I want the video analysis acceleration. So kill that one and select. There's my new one I created. Hit done, and there's my acceleration data. So I've got some acceleration data. It looks like I'm going to check the scaling on this, as it looks like we have a little bit of a scaling issue here. Graph options. Our labels, it's fine. We'll auto scale from 0. And you can see we have some positive numbers. I want to show all of this here. Let's do auto scale. Well, this auto scale isn't working too well, or maybe that's just the top of the scale. What I'll do is I'll go from maybe +1 to -2. Let me do a manual scale. So I'll change since it's not working too well doing the manual scale, maybe I'll start up at 0.5 and go down to -2. Alright, and so here you can see our acceleration. Doesn't look like constant acceleration to me, folks. And now you can go ahead and line up your graphs. There's my acceleration. I'm going to have to squeeze this graph a bit to fit everything in. And the downside with my computer that I'm using, this is a letterbox format display. If I had a larger traditional display, which has a 4:3 aspect ratio, I'd have more vertical room to work in to create these graphs in a nice fashion relative to my video here. And I don't really need to have this video showing if I don't want. I could cover that up if I'd like. But here's a position, velocity, and acceleration graph. Now I could do some things like, for example, what if I want to try to fit see if this fits a parabola nicely on my position graph, to see if perhaps it's a nice parabola that we'd expect if it was constant acceleration. So I'm going to select all my data up here if I can get to pick them all up. And I'll go ahead and try a curve fit to this. And we're going to fit a parabola to it. Our time offset. We actually start at 0, so I don't have to do a 0 time offset on this. I'll try a fit on this. And it actually does come up with a function that's fitting theoretically as a parabola. Let me just hit OK on that so we can see it. But if you actually look carefully at this graph, and I'm going to zoom this graph out a little bit. Let's see how well it fits. If you look at this graph, it's coming through here, and right here the dots are above, and all of a sudden they shift to everything's a little bit below. Then all of a sudden everything's all above again. Then all of a sudden everything's below again. If you look, this is shooting up over here, but really it should be rounding off if this was since we're starting at a 0 velocity technically with this object. So this is not necessarily a true parabola shape, even though it fits somewhat closely to our line. It doesn't look like we're going through it nicely, even though it looks close. So you got to be careful about interpreting these things. Even though it looks like we have a decent fit here, this is a very flat parabola. And if you were to figure out where the vertex on this, the vertex should be right here. But if you were to look at this data and figure out where the vertex is, you're going to find out that we're not close to our vertex at this point over here, I don't think. So a parabola is not the best shape for this. This looks more like a linear function, if you ask me. Down below here, I don't know what shape is this. It looks like it's sort of curving down here, but it's sort of flat a little bit, then flat over here. And I'm not sure if there's any type of curve fit we can do on these. Let me try to do an integral and see what kind of see if I can figure out on the velocity function. Let's select all the data. I want to find the area under this curve. Let's just see what we get. So actually the time axis is up here, the 0 axis up here, so we actually have all this negative area down below here. And if you look at the negative area, it's giving us negative 4.663 seconds times meters per second, or this ball has dropped negative 4.7 meters. And you'll notice my last dot here, I didn't actually go all the way to the ground. I'm a bit above the ground for whatever reason. And we were 5 meters from the top here to the bottom. So it looks like this areas are actually our displacement for our entire drop here. So it looks like that actually did work. Our acceleration graph, I don't know how you're going to interpret that. It looks like we have fairly constant acceleration over this interval right here. All right, so that interval on our top graph from here to here, that I'd be a little bit more comfortable fitting a parabola through that section, because that looks like it's more so constant acceleration. You could actually figure out the acceleration of that point in your graph, perhaps. Now, why did it dip down into a positive acceleration? Did the object actually start moving upward? Does that mean? No, it just means it started instead of speeding up, it actually for some reason slowed down. And that was about 4 steps back. Why would that object all of a sudden, instead of speeding up towards the ground, start slowing down a little bit as it headed towards the ground? If you could think of a reason for that, maybe I could give you a bonus point. So post something up there if you think of that. So that's how we could do some further manipulation and add in additional columns of information, take out columns that we don't like, and so on and so forth. Have fun.